One of the most important concepts that you learn about in programming, regardless of what language you are learning, is the concept of functions. Functions give us a way to group together collections of statements and or calculations in a meaningful way and give them meaningful names. Now, in many ways, the concept of a function is something that you should already be familiar with because they're covered in basic math. In math, you are used to being able to say something like f of x equals x times x. This basically takes the function x squared and gives it a new name. We call it f. And in the field of mathematics, you do this so that it allows you to think of these things in a more abstract way. We can think of a function not specifically as x squared, but just as f of x is some function of x that has some properties. When we're doing things in programming, that whole ability to think of things in a more abstract way is very helpful. But we differ from math in a number of ways. Some of the main ways are the names that we will choose for things. Just like with our variables, I don't always give my variables the names like x and y. I give my variables longer names like age or ticket price, things that are meaningful to me and others when I read them. For example, here, I might not call this f, I might call this square, because that's actually what it does, and it's a more meaningful name to us when we're working with things. Functions also help us with breaking problems down. So we can take a problem that is very large, and once again, this is one of the central concepts of programming, is we want to take a large problem and break it into small problems. A general rule that I tell my students is never solve a hard problem. If you have a hard problem, break it into easier problems and then solve the easier problems. And in fact, if your original breakdown, the things are still hard, then you break them down further and further so that you're never actually solving a hard problem, you're just converting a hard problem into lots of easy problems, and then you solve the easy problems. Giving things meaningful names and breaking them up into pieces also makes it easier to read through code and to maintain the code, as well as also to fix bugs in code. One of the things about functions is when you write a function, you can check and make sure that that one function works. And then you can check to make sure that all of your other functions work. And if each function works independently, you feel much better about how they will all work together. Now, it turns out that Scala doesn't use quite this same syntax here. We have to make a few changes in order to turn this into a Scala function. First, we are declaring a function, and as with all declarations in Scala, there is a keyword that we use at the beginning of a declaration. For variables, it was val and var. For our functions, it is def. So I'm going to define the function square, and it takes one or more arguments, which go inside of parentheses and would be separated by commas, but also I have to specify the type. And when you were doing functions in math, the type was numbers. Everything was numbers for the most part. In programming languages, we have to be more explicit about that, and so in Scala, we have to specify the type that we want to work with. In the case of x here, x is a perfectly happy double. Double is a very good type for doing kind of our general mathematics. After the parentheses are closed, you specify the result type, what this function is going to produce. In this case, when if you square a double, you get back a double. Now, it turns out that this type here is optional in most cases. I do not have to specify this. Scala can figure it out, and Scala can look at this and say, oh, x is a double times a double is another double, and it will figure out that this gives us back a double. However, it's good to get into the habit of putting this type here, and especially for any function where the return type isn't immediately obvious. In this case, it's so simple that it is obvious. But if it's not immediately obvious, it's good to get into the habit of putting a return type. We'll also see later that there are some situations where you have to put the type that the function is going to produce. We follow that with an equal sign, and then we put an expression over here. Now, if the function were large, we would use curly braces, and then we could have multiple lines of stuff and make one large expression. If it's short, we can leave the curly braces off and just define it like this. So that is our first definition of a function in Scala. And whereas in math, if I had said f of x was equal to x squared, I could then say something like f of 3. The syntax for calling a function is actually very similar to what it was in math. We simply give the name of the function, and then in parentheses, we pass in the argument or arguments to that function. We'll come back next time and we'll talk about how we can make more complex functions that are longer, and we'll go into some of the details of things that are passed in and their results.